Hi there, my name is Alex, and welcome to my presentation. Today I'm going to be taking a look at FreeCAD's Fasteners workbench. This workbench is intended to be used for adding fasteners and threads to your FreeCAD models. I'll walk through the basic usage of this tool, as well as take a look at a few of the more advanced features, then finish off with a discussion of how you can get involved with the workbench's development. The Fasteners workbench is hosted on GitHub at the repository shown on this slide. Links to the code, as well as all of the examples I'm going to use today, and some other related items will be in the final slide of this presentation. The workbench is developed and maintained by a sizable group of people, including myself. To add the Fasteners workbench to your FreeCAD installation, I recommend using the add-on manager. First, let's look at the basic usage of the workbench. Let's say I want to add a set screw to the hole in this model. I can select any circular edge that I want to add a fastener to, then click on one of the fastener type buttons in the workbench toolbar. If the pass hole toggle button in the toolbar is checked, the added screw will be small enough to drop into the selected bore. On the other hand, if I switch to the tap hole mode, newly added fasteners will be sized according to their corresponding minor thread diameter. If I want to change the properties of an existing screw, I can select it in the 3D or tree view, then use the Properties Manager panel to update the length or the diameter or the type of the fastener. By default, standardized lengths are used, so they're available in discrete increments, but I can also specify custom length fasteners by switching the enumeration property to the custom option. Just keep in mind that fasteners that have a custom length aren't necessarily going to be available as off-the-shelf parts. I can also toggle modeling threads on and off. A caveat with using modeled threads is that they can be fairly computationally intensive to generate, so you should only use them for models where they're strictly necessary. The direction of a fastener that is attached to a geometric feature can be inverted using the flip command in the toolbar. I can also move a fastener to a new location using the move command. Changing the offset parameter in the Properties panel will move the screw along the central axis of the attached feature. This is useful to add space for a washer or a mating part, for example. Another feature of the Fasteners workbench is a set of commands to add modeled threads to existing parts. Let's take a look at how to do that. This part is a kind of stub shaft, and I want the shorter side of it to have an M30 thread with a finer than normal 2mm pitch. I'll first add a screw die object to the active document using the appropriate toolbar button. I can change the diameter and the pitch to match the shaft that I want to create, and I will set the length property to be as long or longer than the section of the shaft that needs to be threaded. I'll also make sure to change the object to use real modeled threads. I can then use the transform tool to position the thread cutter in the correct location relative to the base part. Finally, I can use a part design Boolean operation to subtract material from the shaft. If you aren't using part design bodies for your designs, don't worry. You can also use the part workbench's Boolean operations to work with thread creation features. Let's take a quick look at some of the secondary functions of the Fasteners workbench. The Bill of Materials command allows you to create a spreadsheet listing all of the fasteners that you used in the active FreeCAD document. It should correctly account for any duplicates and linked objects, and will list each used fastener by type and quantity. There is also an included command to add countersink and counterbore features to existing holes. However, for the most part, this functionality has been superseded or replaced by relatively recent additions to the part design hole feature. Finally, the screw calculator command acts as a fast reference for the required tap drill diameter for screws with standard coarse threads. If you are interested in getting even more functionality out of the Fasteners workbench, one way of doing that is to combine it with one of the available assembly workbenches. Fasteners objects should behave well with Assembly 2+, as well as Assembly 3 and Assembly 4 models. Fasteners can also be used more generally as geometric primitives in solid modeling operations. For example, this assembly features a part that is a weldment of a formed metal piece and a hex head screw. If you are interested in getting involved with the development of this workbench, there are a few ways to do so. If you are comfortable programming in Python, consider opening a pull request on GitHub to add a new type of fastener. We've put quite a bit of effort into making the structure of the workbench's code modular so that a new type of fastener can usually be added with only a couple lines of Python, as well as some CSV tables that specify the dimensions of the fastener. If you're not comfortable with programming, a well-written issue on GitHub asking for a new feature or documenting a bug is also appreciated. And that is everything I have to show for today. This slide has links to the Fasteners Workbench repository, as well as the main FreeCAD forum thread associated with the workbench. All of the examples I showed today were created with FreeCAD version 0.20.2 and are available to download. If you have any questions about this talk or the workbench, feel free to reach out to me via GitHub, the FreeCAD forum, or by email. Thank you for watching.